You two were supposed to help me remember.
Oh, for Anna. Yeah.
Wait, did you record yesterday?
Wait, how was this?
Yeah,
Is it pause?
I did. Now, did I remember to load it to YouTube and send it to you? That's arguable, but I definitely made a recording. Oh, and I was late starting it, much like poor Anna.
Okay.
Sorry,
I'll have,
I was wondering, a bunch of people just walking around.
Those people walking.
Yeah, we're off to a real strong start. Let's go, guys. Everybody. Okay, all right, and let's see. I want to know how. So when I tell you that the radius of the patch is increasing at 30 miles per hour, does that mean, or 30 meters per hour? Does that mean that the radius is equal to 30? No. It's the change in the radius with respect to time. So the fact that I gave you a change, a rate of, if you will, means that we're going to throw this into the D1, D2 notation, okay? And in this case, D1 is the radius, okay? And so that is equal to 30. And what am I asking you to find? dAdt, the change in the area with respect to time. So with related rates, the whole idea is you take the rates you're working with, in this case, drdt and dAdt, and you have to come up with something that relates those two variables. Can anybody think of something that would relate the area and the radius of a circle? That the area of a circle is equivalent to pi r squared. And once I have that relationship, I can take the derivative of that relationship with respect to time. Is everybody good? Yeah. Okay. So, derivative of area is dAdt. What is the derivative of pi r squared with respect to t?
2
2
pi r
drdt.
Okay. So, are you guys with me? If my radius changes from here to here, that's a, versus from here to here, the amount of area it's changing is a lot. Do you guys see what I'm saying? Okay, so this is a bigger area than, say, this one. All right, so we need to know that if we want to find the change in the area over time, we need to know at what point in time, which in this case we've described as the radius being 100 meters. So now I say, well, I want to find dAdt. I know the radius is 100, and I know that the radius is changing at a rate of 30 meters per second. And then I'm going to pretend I'm smart by letting you guys type this in your calculator, and I'm going to just pretend I knew the answer. 600 pi
That might not be right.
meters squared per second. No, it'd be 600 pi. No, 6,000 pi.
Yeah, I was like, that's
6,000 pi.
I got 18,000.
And then that is equivalent to 18,800, is that right?
18,850?
Where'd you get seconds? Should it be hours?
Yeah. Sorry. I did that this morning too. And I think it's because I think about meters per second squared and not meters squared per... I'm just not smart. You guys shouldn't listen to me ever. Good thing I put that on record for everyone to see.
Why is it the meters squared?
Because it's the change in the area. So the area would be meter squared. If you want to look at it, Hannah, from the unit perspective, this was 100 meters, and the 30 was meters per second. So you're doing meters times meters per second would be meters squared per second. Does that help? Everybody good? All right.
What do you want us to do for
Just know automatically what I'm expecting each time. I will rarely, sometimes I tell you where to round, like to the nearest 0.001 or something. If not, as long as you're within reason, you're fine. Everybody good?
Mm-hmm.
Let's look at the next one. 2 small airplanes approach an airport. You are not allowed to make fun of my drawing skills. I am an expert in mathematics. I am not an expert in artistic ability. So this is my airport. It has a roof. Here's my first airplane. That's the northbound one. Here's my other airplane. That's too tiny. Hold on. Fin and the wings. Everybody good?
Yeah.
Okay. And I'm going to go ahead and sketch this here. And what are my variables here? Because these planes aren't going still, yes?
Oh, is it like this battery and zero?
Well, so would you, are you guys okay if I call this distance x
Yeah.
and this distance y for now? I like to try to use x for the horizontal distances and y for the vertical distances. It certainly is more connectable for you guys. Okay? All right. And man. So let's go through and look through this information we've been given. The one flying due west is flying at 120 miles per hour. What does that mean? dx dt is equal to something. But what's happening to dx dt? Or what's happening to x? It's getting smaller by 120 miles per hour. Is everybody with me? So what is dx dt? It's negative 120. And likewise, what can we say about dy dt? Negative 150. Lovely.
This is because they're getting closer and closer to that airport.
So the change in x is that it's getting smaller by that amount.
I got you.
Okay? And let's see. We want to know how far is the distance between the two planes. That's this distance. How fast is that changing? Yeah?
Okay.
Okay. You guys, I'm going to call that distance C. Do you want me to call it Z? The other class was like that too. Originally, I called it D, and then I had D, 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 D. D, 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 T, and it felt a little icky. I was calling it the C of A squared plus B squared equals C squared. Are you comfortable, too, if I say X squared plus Y squared equals C squared? All right, and in the precise moment when the westbound plane is 180 miles from the airport and the northern bound plane is 225 miles from the airport, how far are the two planes from each other?
Why do we need to know that?
You'll see.
Because it'll be like 2C, DC, DC.
Do that in your head.
288.14. 1.
Okay. All right. So, to find dc dt, we're going to take the derivative with respect to time. So, 2x dx dt.
Wait, what's the D?
You're taking, what I'm saying is we're taking the derivative of the entire equation with respect to time.
Why?
Because we're trying to find dc dt, which means we need the derivative of this side. We good? fill in everything we know, and all we have left is dc dt. Then it just becomes a...
How do you?
You sure?
Yep.
I need 192.
Yep, that's what I got.
Was this a 0.14?
I'm sorry?
288.4.
1 4.
192, is that what you got?
We all got 192?
Miles squared per hour. It's negative.
Negative 192?
Yeah, it's decreasing as it goes.
Negative 192 what?
Miles squared per hour.
Miles per hour.
It's not squared. Oh, because it's not.
Because in this case, it's distance, it's length. What do you guys want to talk about?
No, that makes sense.
Oh my god.
Are we good? Do we need to talk about it? Oh, this next one's beautiful. You ready?
You're bold for doing this.
I love related rate. This is like by far my favorite math topic to talk about.
It makes more sense.
I mean, everybody has their thing that they love, right? For me, it's calculus and related rates. It's beautiful. It is beautiful the way this works out.
When you first took calculus, were you like, this is it, this is my life?
Related rates were the first time, not the first time I was ever challenged in a math class, but it was the first time like I really put in the work and got it to a place in a way that I didn't like. It was a moment of synthesis of all the math I had ever learned, finally making sense as to why I learned it. Yeah, like it was pretty great. It was actually conversations with my math teacher about related rates are why I teach high school math and not third grade. Which, knowing me now, thank God for Mrs. Hartman, man. She was the best. Okay, thoughts on this?
The radius is 3H. I don't know if that's necessary.
So, no, I think that's helpful, that the radius is equal to 3 times the height. That's lovely. What else?
The rate of the sand is falling at a rate of 120 feet cubed.
Okay, so you guys, if it's 120 feet cubed per minute, what is it?
DV?
Yeah, because feet cubed, so it's dt because it's per minute, right? And feet cubed is volume.
Right. So dv/dt is equal to.
So I know dv dt is 120 feet cubed per minute. But are we good at, you can use that unit to see that this is a dv dt.
Yeah.
And the minute I know that it is a dv dt, that tells me what my relationship is going to be. It's going to be the volume relationship. Does anybody remember the volume of a cone?
No. It's the triangle times the height, right?
1/3.
It's something I don't
Triangle
know.
times. It's one time.
Don't
Okay,
we
wait,
get it?
I got it. 1/3 height times base.
Oh, because we also need the base
Okay,
to be the
I get
circle.
so 1/3.
1/3 pi r squared.
Times height.
Height.
Yes, we did it.
You guys,
I would never.
I am impressed.
I would not have done
I just want you to know, I am super impressed.
Well, it makes sense. I think.
The question is, will Miss Meister give this to you on the quiz?
No. Or wait, the formula? I know.
The formula.
No.
Hannah, that was fantastic. You guys, I totally forgot to write it on the quiz, so when you get to the question and you're like, oh, I don't remember the formula, just say something and I'll put it up on the board. Okay? I did not put it on the quiz, but that was not intentional. That was just, the same reason why you have to make corrections on that one in your homework.
So everyone was right. No, and yes.
Yeah, isn't that lovely? You guys were both right.
Yeah. No, and yes.
But Hannah was the only one fighting for you, right? She said yes, like so matter-of-factly, so that even if the answer was no, I would second guess whether I should do it.
Expect the worst and hope for the best.
Okay, you guys, can I do this right now?
Um,
Yeah.
yeah, because R is 3H. So you just have H.
Okay, so the thing is, if I were to take this derivative right now, I would have a dv dt, a dr dt, and a dh dt. Okay? And I don't have enough information because I don't have anything else about this radius, other than it's equal to 3 heights.
Can you change the R to 3?
So, what we're going to do, r is 3h.
Oh, big brain.
And if r is 3h, how can I simplify this equation?
You can plug in the 10, right? Doesn't it want that?
Not yet.
Okay. Oh, because we haven't. Okay.
You guys, what is 3h the quantity squared?
90
Okay, so if I simplify this, I get 3 pi h cubed.
3 squared is 9.
I agree, but then with the 1/3, it becomes 3 again.
Times H.
Dun, 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 dun.
So 3 pi H cubed. Yeah.
It tells you the whole time that the radius is 3 times the height.
Capital H instead of
And by the way, is this a tall, skinny cone or a short, fat cone?
tall skin.
Wait,
I don't know.
why
'Cause the
is
height
H-
is
short.
Why is h cubed in the, oh.
Short.
Because the radius is
Are you good? He- Quinn, I'm glad you were thinking about it and not just writing it down to follow along. That was great. Hey, you guys. Now can we take our derivative?
Yeah.
dv dt is 9 pi h squared times dh dt. Hey, what are we trying to find? I always forget this. How fast is the height of the sand pile changing?
You're trying to find DH dt.
Okay, so great. So we'll fill in everything we know. What do I know about dv dt?
120.
120 equals 9 times pi times at the moment we're trying to find the height is 10 feet.
120 over 900.
Oh, we're trying to find the HTC.
2/15.
It's the how fast
Oh, it's squared.
is the height?
Where did the 10 come
Because it's a rate, right?
This is 10.
So it's feet
I got
squared per
4
minute. Is that right?
So Hannah, so you good?
Yeah. Wait.
Oh, it's 900. Four over 30.
Which is like, I don't know, 0.04?
2 over 15.
That's what I got.
2 over 15.04?
I just
Point one,
I got
point 1, 3, 3,
I got
3.
I got point.
Point oh 4.
I did not get point
What am I doing?
I have that. I just simplified it down.
With the pi, if we included the pi.
I just made it a fraction in height.
And you're divided by 900 pi?
I got 4.
Oh,
Because that 10 is squared, yeah?
I got the 1 4 now. Yeah.
Point
Flipped
4.
it as a
Okay.
fraction.
I got
Point-
0.418. Yeah, that's what I got.
Whatever, guys. I got 0.419.
Oh, okay.
Oh, if you round.
I did.
And that would be feet
Per minute.
because it's not a acceleration rate. What is the rate?
Isn't this fun? Yeah, I'm listening.
I know. Do you have candy?
Sorry, I love you.
When doesn't she have candy? Do you ever not have candy?
Yeah, when I run out. Because kids always eat
You
it.
don't restock before that? You can always go get something.
I love how you sit it.
Wait, you should
If
just
you
steal one
knew
candy
where all the
supply one day.
how many
I
candy
think-
spots there are in this building, I'm surprised McCarthy hasn't come in here and asked me for candy because he sometimes does. He did that once. Richards usually has chocolate. Almost the entire math department, with the exception of Mrs. Downer, because she's smart and doesn't keep it near her, so she doesn't eat it, has candy somewhere. Almost all of us do. because we're
The best
sugar
way to
addicts.
do it.
Hey guys, let's do this one. There will be plenty of candy the day after Halloween. Because I'll go to CVS that morning and load up, or to Giant Eagle that morning and load up when it's on sale. But then I run out of hiding places in the
Just go
classroom
trick or
too.
treating, get the candy for free.
Yeah, no. Hey guys, let's draw a picture of this one.
Extra credit.
Triangle.
No, that's a hot one.
But it becomes a
Oh.
triangle. It's deceiving.
Here's the person. And I know that this is 200 feet. Thank you. I'm doing, like, I didn't even read it. I'm doing it from memory. I just remember the 200.
That's all that really matters. So we have nothing else. We can-
Okay, let's see what else we got. The balloon rises vertically at a constant rate of 4 meters per second. So this is going up by 4, and I'm going to call that variable y.
So is that
Why?
DHDT?
So that would be dy dt. Hey, if you chose to call that variable h and called it dh/dt, I would understand exactly what you're saying. It's
Okay.
fine.
Isn't it 0? Because it's constant.
No, it's 4. The rate is 4.
If it was originally before X.
So if I wanted to come up with a function,
Oh, I was thinking of acceleration. Sorry.
you're good. Are we good? All right. And what are we trying to find?
We're trying to find d whatever dt, which is the.
I'm gonna.
angle.
If we're trying to find the angle, which I'm gonna use theta. So what we're trying to find is d theta dt.
Yes.
So as I'm trying to come up with my equation that relates my two quantities, I have to relate the angle to y.
The other one is
Is it opposite over tangent theta
So my equation will be
something tangent?
tangent theta equals
4 over 2.
4 over 200. I'm going to write that as 200 tangent theta equals 4.
4 the rate.
Yeah.
4 is a rate.
Oh. Yeah. So y.
4y.
So y equals. Because y is just the height, yeah?
200 tangent.
I just multiplied.
Oh,
I'm gonna write that out because I'm gonna look back and understand what I was talking about. Y over
Yeah, I mean, you guys, I'll write it that way. That's
That's
fine.
okay. I just be forgetful.
And if it helps you then to rewrite that as y is equal to 200 tangent. There's lots of ways to think about that. Okay, you guys. Now what?
We need to take the.
In order to find d theta, we need a relationship with that includes d theta, which means we're going to take the derivative of the function that has a theta in it.
Hooray.
wait, can you repeat that?
Okay. Our goal, in order to find d theta dt, I somehow need a d theta dt in my thingy, yeah? In my equation. So in order to make that happen, I need to take the derivative of my equation. So I'm going to get dy dt equals 200 times secant squared theta d theta dt. I'm sorry.
What?
Nothing. All right, so now what?
4 equals. Move it. No, why not?
Well, plug in 4.
Plug in every-
y dt.
I can plug 4 in for dy dt. Lovely. We got another problem, though.
We don't know.
We need a value for secant squared theta if we're going to be able to solve for d theta dt.
1 over, what is secant? 1 over cosine. So what? 1 over, the cosine here is, well, we have nothing. We have nothing. We have no
We have time, it's 30.
Oh my god, that was great.
That was about.
No, it really was. Cause like, you guys, what you guys don't realize is I can see, like, all of you guys are saying little things under your breath, and I can see your mouths moving. So like, I know what you're saying, but you guys don't hear what each other's saying, and you're all like super frustrated with a concept. You guys, it's a challenging concept, but it's like you're all expressing yourself in this like, not necessarily disrespectful. Just like really vehemently hating this, like, and you're trying so hard to be respectful, and I just love it. Is it possible? It's totally possible. Yeah. There is a piece of information we haven't used yet. Somebody was saying that there's a. Yeah. So do we know how tall the balloon is if it's been traveling for 30 seconds? How tall is it?
120.
So at t equals 30 seconds, y is equal to 120. Because, okay, come on.
We might need to write how we got there.
Because it's traveling at 4 meters, 4 meters per second for 30 seconds.
I see.
Okay? And you're right, this is not an obvious thing.
So the seconds cancel out.
And the minute I do that, I have a bunch of options to figure out, well, what is the secant of theta?
Oh, could we do the find this distance at the hypotenuse distance?
That's how I would choose to do it. That is not what the morning class told. I'm going to show you guys.
What's
So-
the easiest? Let's do that.
That's what I was thinking.
Yeah, if you wanted to do the Pythagorean theorem
I'm good on
to
that.
find that length,
Yes.
that would be fine.
Is that what the morning class did?
Not at all.
Oh, well, I'm doing.
They did the tangent inverse of theta.
That's actually.
They did tan inverse of 120 over 200, and got theta figured out what the angle theta
That
was.
sounds actually exhausting, and I'm not doing that.
It's arguable as to which one's more exhausting. And then they took the secant of that angle and then squared that secant.
233.24.
Yes.
You guys, what was under the square root? Or did you do it all?
It was 54,400. Is that really easier to write than 233?
I just don't like decimals. And the fact that I'm going to square it because it's secant squared makes it a little bit like... Hannah, where are we at? You okay?
Yeah.
Okay, so secant is hypotenuse over adjacent, yes? So that would be the square root of 54400 over 200, and then it's secant squared, and then solve.
What the heck?
Where'd you get the purple equation?
I got 272.
I took the derivative. This one?
I got a negative.
There are 4 minus 272.
Daria, are you in radians or degrees?
Radian.
Oh, that shouldn't make a difference, actually, if we do that this way. You got negative?
I have negative 268.
You guys, you're doing a positive divided by a positive. There's no way you got a negative.
168.
I got
Or no.
0.014.
Sorry, I subtracted it.
Yeah.
Oh, it's
Ignore me.
I mean, I
Sorry.
tried to get it right this time.
Sorry. Why do we do that?
You're looking at the email you just sent me.
Wait, what was
Am I in trouble?
1 over 68.
I did.
I got
I
point
did. It was
014.
like
Yes,
That's what I
1 over
got.
68. And
Wait, you guys are all at the same place without me?
meters. The half
Oh, I saw it.
Did you?
I saw it last night.
Oh my goodness.
You know what? I'm like a little bit mad about it, but no matter what, I'll show it to these guys because they really don't want to do the last example today. They're pretty fried.
And they're seniors though. Hopefully it'll be open in May.
It's hopefully.
I'm hoping so
One of the things I saw on social media, did you notice the sky in the video? They really nailed the Ohio sky. It's like all gray and cloudy. Hey, did you guys end up with 0.04 radians per second? Or per minute? Per second?
Radians. I
Point,
said meters per second.
No, because it's the angle.
because it's the angle. Is this what you guys got?
Yeah. I was actually just
Radians per second, because it's the.
Yeah, this went through the Mean Girls thread last night, and everyone's like, math. I don't want to write it. And I'm like, are you kidding?
Oh my lord.
I
I want to know what happens to you get to the point. Does it get there and stop? And then
Oh,
it
hold on.
tilts and
Hold
drops?
on, though. It took me to a completely different place. It took me to a completely different video.
How does this have to do with the White House?
Look at the headline I was trying to show you guys. Let's try this again.
Mr. Richards has emailed this link so we can see.
so me and Ben both did.
Oh, here it is.
The sky.
Look at the sky.
Hey, hit pause. Hit pause. Wait. Like, how do you get to this point?
That's what I was telling you about.
So if are you writing it, and then when it gets to there, it stops?
It has breaks.
Well, that's what I'm saying. So it stops when it gets there, and then.
Oh,
Yeah, but like that stop and then waiting for it to happen, that alone.
that is insane.
I think it hits 6.
And then you're sitting
This is
there.
about Raven. in
Then
the
you're
background.
sitting there and
Oh
it
my
waits.
God.
And then the rest of it looks fine.
Oh my gosh. I'm
The
so
rest of it looks
excited.
really fun. That's so.
And Top Thrill 2 reopening at the same. And this isn't
I'm
like,
gonna go into the park this year.
and this isn't even taking away one of the good ones.
Huh?
You going on all the rides?
No, like